Okay, here's an equation. Log base 3 of 6x equals log base 3 of 6 plus log base 3 of x. Log base 3 of 6x equals log base 3 of 6 plus log base 3 of x. Let us go ahead and reduce the equation to one log. So the first thing I'm going to do is I'm going to maybe condense the right-hand side of this equation. So we'll condense that. So I've got log base 3 of 6x on the left-hand side, and that's equal to log base 3. We have log base 3 twice, so we're going to keep the base, and we're going to multiply the arguments. So I've got log base 3 of 6x equals log base 3 of 6x. Well, that looks identical. It's kind of like saying x equals x, or 3x equals 3x, or 4x plus 1 equals 4x plus 1. And you're right, it does. So we've got log base 3 of 6x equals log base 3 of 6x. This is a unique equation. Normally, anything is going to work. But let's set this equation equal to 0 and take it a step further. So let's use a little bit more algebra. We're going to condense, and then we're going to set the equation equal to 0. So one step is to condense. Another step is to set the equation equal to 0. So we'll have log base 3 of 6x minus log base 3 of 6x. It looks like we're subtracting something from itself, but we're going to keep going. Now we're going to have log base 3, and we're going to condense again. So we're going to condense again. So now I've got my positive logarithm. 6x goes in the numerator. The next logarithm is negative, so that argument goes in the denominator. And we get 3 to the 0 equals 1. So anything is allowed. Any value of x is allowed. That's what it looks like. Any value of x is allowed. Wait, hold on. Here we say all real numbers. All real numbers will make this equation true. All real numbers make this equation true. And here where I had 4x plus 1 equals 4x plus 1, all real numbers makes this equation true. However, do all real numbers work here? Do all real numbers work? Well, what numbers are not allowed? Remember, 6x has to be greater than 0. 6x has to be greater than 0. Therefore, dividing both sides by 6, x has to be greater than 0. So any value of x is allowed as long as it contributes to keeping the argument positive. To keeping the argument positive. Therefore, x is greater than 0, or we can say 0 to infinity. The easier way to say it is x such that x is greater than 0. X such that x is greater than 0. That's the set of all the numbers that would work. So that's a good one. Okay, we're going to come back and we're going to explore a few more. So we're going to explore a few more different types of logarithmic equations. We've got quite a few examples to go through just to see if you've got it. But make sure that whenever you've got that variable in the argument, you are checking for extraneous solutions.